Hello, and welcome to today's webinar. It's co-sponsored between the Center for Automotive Research, CAR, and SEMI. And we're putting this together to talk about the chip shortage impact on automotive, which anybody who's in the automotive business knows that this is a tremendous impact. We've seen earnings reports for third quarter start to come out, and the impact is truly being seen in those figures. And we also, have heard a lot of things about when this is going to end and what we can do to really try to expedite and manage the situation. The focus today is going to be on, yes, that's happening, but what should we be thinking about to do differently in the future? And I'm joined today by some excellent panelists. And the order is going to be, first, we're going to hear a great presentation from Andreas Breiter from McKinsey & Company, and then we'll have a good dialogue with Dave Anderson from SEMI, John Bozella from the Alliance for Automotive Innovation, and Ann Wilson from MEMA. So at this point, I'd like to go ahead and hand over the podium to Andreas to give us a wonderful presentation to kind of put this all in scope. Over to you.
Thank you very much. Good morning, good afternoon, everyone. Thank you very much for joining us. I would like to talk about demand and supply trends in semiconductors, and specifically to the chip shortage in the automotive industry. Before I come to the shortage, I actually want to start a little bit also on a positive note. So the semiconductor industry structurally improved quite a lot over the last decade. What you see here on this chart is economic profit creation across all segments, not specific to automotive, really all semiconductor segments, including goodwill, in $1 billion. We just see that year over year, there has been an upward trend of economic profit increasing. At the same time, we have seen that over the last decade, the industry was really working at a high utilization of capacity. There was not a lot of slack in the system. We saw that during the dot-com bubble and again during the financial crisis, there was a short downturn or a short opening up in capacities. But really very quickly, we were back to something between 80 and 90%. Interestingly, something that was different this time is that we did not have such a downturn in capacity utilization. So you see that in 20, basically nothing happened. We just stayed utilized. And now coming to the shortage, I think everyone has seen a lot of those articles by now. The chip crisis really hits all sectors. I'm talking now mostly about the automotive industry today, where the chip shortage really stops production lines. In some countries, plants have to partially ramp down or completely ramp down. And this obviously is impacting the industry quite a lot. So I would like to talk a little bit about not so much how we got here, that also a little bit, but then also really think a bit, okay, what can we do now and what can we do especially in the future? As said, the challenge is across industries, and that's due to its root causes. So if I think just about what is the root causes here, first of all, we saw a demand spike last year. Growth has doubled compared to what we were anticipating. And that is because to the digitization boost that we got, not partially at least due to COVID. At the same time, I said we already have been at a high and steady growth in utilization. So there was not really a lot of capacity left open in the semiconductor industry that could serve that spike in demand. On top of that, given that there was a shift, an ongoing shift to foundries, on the positive side, it's now much more easy to allocate volumes across sectors. On the disadvantage of that is if then one sector has a downturn and then comes back at some point, those capacities have been reallocated somewhere else. And then we have mega trends. For example, electric vehicles, ADAS, 5G, which increase the need for chips in our products. And as a result, that even the shortage hits us even harder. Finally, it's just not something we can solve quickly because I think as everyone is aware, it takes time to produce chips. It takes even way more time to set up more capacity. Here we see the different sectors, 2019 sales on the left-hand side, and then the 2020 forecast versus the actuals. So what did we think at the end of 2019 would happen is the gray line here in terms of growth. The blue line is what actually happened. So what we see is that most sectors have been growing significantly more than what we were thinking, with two exceptions. Industrial just being slightly below expectation, but in automotive, instead of a quite significant growth, we had actually a quite significant decline in demand. And that is something that just walked through the whole supply chain. So at the moment that capacity ramped up and then came back, we had a shock, and that shock amplified as it went through the supply chain and was one of the reasons for the shortage. I talked before a little bit about the reliance on foundries and how that leads to a dynamic relocation of capacities. In the auto industry, as we are moving down to smaller nodes, we more and more have a reliance on foundries, just given how the capacity structure in the industry works. So there's only two IDMs at a capacity at 40 nanometers and 28 nanometers. And if we move to even smaller nodes, we will have more foundry reliance. So what that means is that on the positive side, I said more dynamic allocation of capacity, but then on the other hand, also a competition between sectors. So the automotive industry is then competing for chips with other sectors. I would like to talk a little bit about what is the impact of that shortage. Starting off with what is actually the cost for the auto industry versus, for example, mobile phones. And this is just an exemplary calculation back of the envelope, so you can obviously change those assumptions. But I think it's quite telling. I think we are getting some echo from some side. Thank you. So if I just calculate through the gross profit per car times the number of cars that I cannot produce because I'm missing one wafer of chips, I'm coming to 1.6 million opportunity cost for one wafer in lost production profits. If I would do the same, for example, for a phone OEM, it would only be $134,000. So really, the auto industry fortunately needs those chips because it is actually creating quite havoc on their economic profits. Yeah, profits is one thing, but I would also talk a little bit about jobs. So this is an Europe example for Europe. If I do a similar calculation for, okay, with one wafer of chips, 50 chips per car, I can produce 30 cars per wafer. Then if I just assume that one job per 7 cars produced, 4 European jobs depend on one wafer produced, and you could do a similar calculation for the US. Yet, as we know, it's not that easy to resolve in the short term. The production time is greater 4 months. So that still sounds theoretically okay, but then as soon as we get into really having to develop products, alternative products, or even going into capacity buildup, as we see, that is very quickly getting to a very, very long timeline. So not anything that we can resolve this year or even next year. I think, therefore, we should talk about two things. The one is, what can we still do in the short term? But then also, how can we make sure we're not getting in a similar situation again in the future? Yeah, as I said, tight demand balance is here to stay. Several points here on the right-hand side. First of all, digitalization is not going to roll back. Well, I think there's a lot of discussions to what type of a working model will go in the future. And it's probably something hybrid, but digitalization is just here to stay. Also, it's hard to predict what stocks there are and when they are going to be released, or if they're going to be released, and how that helps to ease the pressure on the supply chain. And then in the end, we have those mega trends which are continuing. we have, and those affect both leading edge but also lagging edge nodes. So we have, for example, 5G rollout, IoT, which even strains capacity on the lagging edge. Yeah, so I think there's a lot of questions about what can we do. So re-evaluating the supply chain is, I think, one of the key questions we are discussing with players in the industry. So today, what we have is a supply chain that is here, the black line on this chart, really, which is going from OEM to tier one, to LAM design, down to foundry, then back to tier one and back to the OEM. There are several ways we could reimagine that supply chain. There could be a world where the tier ones are more going into the lead. And there could be a world where the OEMs are actually going more in the lead and do direct buys. And then I think that is the big discussion. Is there a scenario of full verticalization of the OEMs? I don't think that a full verticalization scenario is something that we will see on a broad scale, but there's definitely discussions ongoing for some OEMs or some types of products to do that. I think independent of what model we go to, one thing that will be really critical is just seeing this whole thing as a system and keeping communications up between the different levels. Because one point that was creating this bullwhip effect, which we see in the supply chain, is just that if you have a demand shock, you have to communicate extremely well between the different levels of the supply chain to make sure it is not running out of control. So independent of what model we go to, I think doesn't help us. We have to communicate well between all levels. The other point is demand and supply do not match. And I think we can talk about that more later on in the panel. But we are reliant on international trade and we are reliant on shipping chips between regions to match supply and demand. And that will not change in the short run. Okay, now coming to levers. So left-hand side, tactical levers, short and midterm, and then the right-hand side, the strategic levers for longer-term impact. Well, the first point is obviously what everyone is already doing, looking for any inventories that are left and allocating those inventories. So see who has what chips remaining, where could those, which ones could be released, what inventories are not needed or not immediately needed, and where could they be allocated. Second point is any compatible parts that could be dropped in. So, and that might be actually higher spec and over spec parts, which would obviously increase the cost of the product. But as I've shown you before, the opportunity cost is so high that that probably makes the sense. Designing alternative parts, that will take some time, but could at the same time then just diversify. One thing we have to be careful about here is to make sure it's real diversification, not that we are then sourcing afterwards the alternative part from the same source, and then it's just diversification on paper, but really in the end doesn't help anything. Yeah, so that is on the supply side. The other side is then just minimizing the economic impact of the shortage. So instead of not producing a car, could we take certain features permanently or temporarily out of the model? Not an easy thing, because many things that are driven by chips are actually important differentiators. But still, before producing no car or fewer cars, is that an option? On the strategic side, on the sourcing, reassessing which categories are more vulnerable and how can I source those, manage them as a commodity. And the question is who in the supply chain would actually take care of that? Is it the OEMs at the tier one, as discussed before? The second point is all about the communication. So how can we enhance transparency across the supply chain? Very clearly communicate earlier when capacity is ramping down and up, so that these shocks do not go through the supply chain as it did in the past. and then reassess the strategy for inventory and buffers. How can we make sure we're not stockpiling up at the point when there is, when we see that there's a shortage coming, which then amplifies the shortage? Or at the same time, how can we actually have some strategic buffers ahead of time? On the supply chain structure, yeah, what is the supply chain structure to be set up? And we were discussing different options before. What types of chips do I want to move to a direct buy? For what chips do I want to rely more on my tier ones? Where is the OEM going into the lead? Is there certain chips that should be own designs? And then finally, how can we support capacity expansion, which is in the end then really the solution to the shortage in the long run? Yeah, I think I open up to questions at this point.
Thank you very much, Andreas. Great presentation and great food for thought for our questions. I want to remind our audience, I know several of you joined since I've made my first opening comments, that if you have questions, please put them in the Q&A box. I'll be monitoring that throughout. Andreas, one question that I had when I was, looking at the chart with the supply chains and sourcing and then the other one that showed the length of time. Tell me, why is it so difficult? Why does it take so long? What are the batch volumes like? How long does it take a manufacturer to turn that on and turn that off and start building a different spec, so to speak? And Dave, you might have some feedback on this one too, but I think just to give the audience some idea, why does this take so long?
Yeah, well, I think there's two things to it. One is if we need to design a new chip, that obviously takes a long time. Even if we do not have to design a new chip, but there is an alternative product available, we still have to make sure it actually qualifies. Again, we could have a product that is already fulfilling automotive standards and is qualified in principle, and we have to still test that it's actually working in the specific position we want to put it in. So even in the best case where we would have a automotive grade qualified product that is available, that is already designed, that we want to put in our car, we still have to actually validate that it is working at that point. If any of that is not the case, so let's assume it's, for example, not yet automotive qualified, we would have to go through the full validation process. If it's not even designed, that would take even longer, as you see on the chart, which could be 1 to 3 years.
And what is the typical size of a batch run? Do you know that information? Is it X number of thousands, or Dave, does it vary?
I'm sorry, the size of a
Batch run.
Oh.
Before they have to, they run X number of the same spec and then they have to tear down the assembly line, or probably not tear it down,
Sure.
but reprogram it.
We build them in quantities of wafers. Wafer is the silicon slice that the chips are built on. It really depends on the size of the chip. It can be from hundreds to thousands per wafer. And there's typically 25 wafers in a batch. But, once the line is set up, we run, several batches. So it would normally be in the thousands of devices. Yes.
Okay. Great. And as we're thinking about that kind of process in the supplier, what do you think about or just give me some idea about the numbers of different specifications that exist in the automotive industry? Rough number. Do you have that, Dave?
Oh, device specification, there's hundreds. There's
I expected you were going to tell me, multitudes of thousands,
Well, and between all of the chips that may be used, there may be in the thousands, but there's a couple of hundred chips per car today. And so if you look at those, they go everything from the controllers that manage the the systems down to the sensors that are
Yep.
monitoring various aspects of the car. And today with LiDAR and radar and other types of sensor chips being installed, cameras, the types of devices are expanding. And some of the complexities for drop-in replacements are those have to be built to particular environmental specs to be in the engine compartment or outside, and things that a typical chip that goes into a cell phone or a computer doesn't have to comply with. So there are other complexities in the manufacturing process as well.
Yeah, thanks. Those were just a couple questions that I wanted to try to get clarity on from this presentation before I went on and dealt with some of the other questions from the audience. First of all, though, I'd like to have the opportunity to have each of our panelists kind of introduce themselves, a little more detail about themselves and their organization, and then we'll move into the panel discussion itself. So even though, Dave, I've already put you on the spot, I'd like you, if you wouldn't mind introducing yourself, telling us what SEMI is, and kind of, your high level thought on this subject.
Certainly. Thank you, Carla, and thanks for having us. It's been a great partnership working with CAR, and we really enjoy it. SEMI is an industry association representing the microelectronics and electronics supply chain for design and manufacturing. We have about almost 2,500 member companies worldwide, everything from raw equipment and raw materials and equipment suppliers all the way through the device makers and the end systems and OEMs such as Ford and VW and others that are in this industry, but Amazon Web Services, Google, Apple are all member companies, as well as the Intels and the Texas Instruments and the Renesas and NXP, the chip suppliers to the auto industry, and all of the equipment makers that build the equipment to make the chips. So truly representing nearly every element of the supply chain for microelectronics. Over the past few years, we've had the foresight to look at automotive and mobility specifically as a strategic market, and looking at from the aspects of what's coming that's going to drive growth in the microelectronics industry for the future. So clearly electrification, autonomous systems, smart cities and infrastructure, and interconnectivity between vehicles and things like that. To drive technology development, new applications, and of course, growth for the industry. We certainly did not anticipate what happened over the last 20 months. We've been through many supply strained situations before in the past, but this is one that's, really across the board, across all industries. As Andreas mentioned, and obviously the automotive industry, because it's such a large industry and impacts individuals, certainly gets a lot of press, but there are shortages of interesting time to be looking at that. I'm certain that we're living through a Harvard Business School case study as we speak, and it will be fun to look back and see how we resolved it. Hopefully this seminar will be part of the solution.
Yeah, I fully agree with that. There'll be a lot of case studies and lessons learned, not only, in supply chain, but in risk mitigation and future-proofing your organization. So I can see lots of career opportunities for folks coming from this. Our next panelist is John Bozella from the Alliance for Automotive Innovation. And I'd like to give you a few moments to introduce yourself and give us some high-level thoughts.
Fantastic. Carla, thank you so much to you and to the Center for Automotive Research, as well as SEMI. This is a critically important conversation and a timely conversation. So thanks for having us. Let me start where Dave started. Our organization, Alliance for Automotive Innovation, is a full-service automotive trade association. representing the whole automotive ecosystem at the intersection of public policy and automotive innovation. We focus on policies that drive cleaner, safer, and smarter personal transportation. Our member platform is broad. We represent 99% of the OEMs that produce new vehicle sales in the United States, as well as some major tier 1 automotive suppliers, tech companies, and new entrants to the personal mobility space. As Dave referenced, our membership includes, for example, both Ford Motor Company and Intel and Texas Instruments and NXP, as well as companies like Bosch and Aptiv and Cruise, for example. So you see this broad automotive ecosystem, and I think that's what, by the way, makes these types of conversations really important, because between Dave and Ann and myself, I mean, we're representing a lot of the same companies working toward the same goal. And I want to come back to what that goal is in a second. Let me just pick up a little bit on some of the comments that Andreas mentioned. This is a very, very challenging and difficult and painful supply-demand disconnect in the automotive space. There's just no question about that. Just to put some numbers on, new numbers on what Andreas was framing and what you mentioned, Carla, if you look at production in the United States and you look at demand in the United States, I have never in my 25 years in this industry seen a greater disconnect between demand and supply. Demand is strong for light duty vehicles in the United States, roughly in a 17 million unit annual sales rate, which would be among the strongest we've seen, maybe in the top 4 or 5. And yet, we're going to do maybe, 3-4 million vehicles less than that. And so we are definitely seeing a supply-driven challenge right now in the automotive market. Andreas has done an excellent job of explaining why that is. And I want to focus both on the near-term challenge, which is, look, we have this mismatch partially driven by COVID, but we also have this reset of demand. Andreas mentioned them as megatrends. I love that term: more automation and connectivity, more electrification, more digitization of personal mobility. So there's no question that we've got to work together to align, the industry, which brings me to kind of my last point. I do think that while there are opportunities to partner with policymakers, and we'll get into that, I'm sure, during the discussion, I think there's also an opportunity to build on Andreas's point about the importance of communication across the value chain and the supply chain for us together to identify ways that we can further collaborate to make sure that we are providing solutions that are mutually beneficial across the microprocessor supply chain. So I'll leave it there. I look forward to the discussion, and thanks again to you, Carla, for moderating this.
Thanks, John. Great introduction. Our final panelist is Ann Wilson from MEMA, and I invite Ann to come and introduce herself further, her organization, and opening comments.
Thank you so much, Carla. It's really a pleasure to be here, and thank you to you and Semi for pulling this together today. I think, as the previous speakers have said, this is probably one of the most important issues facing our industry, and one of the most important issues facing the members of our trade association. So MEMA is a trade association. We represent motor vehicle suppliers who have a manufacturing presence in North America. We have around 900 members in both the OE automotive space, as well as commercial vehicle space, the aftermarket, and remanufacturing. We represent virtually all the tier 1s in the automotive space. I won't say all of them, but virtually all of them. And I would say that this is one of the most significant issues that is facing them right now. But it's not just limited to automotive. When you talk to the commercial vehicle suppliers and to the truck manufacturers, engine manufacturers, when you talk to the aftermarket, this is affecting all of our members in distinct and slightly differing ways, I would say. I think one of the things that's important, and one I think Andreas kind of touched on this overall, is we actually have over 900,000 direct employees who represent supplier or are employed by suppliers in the United States. We are the largest sector of manufacturing jobs, the largest employer of manufacturing jobs in the US. And what we are seeing is that this is impacting not just those suppliers who actually are purchasers or users of semiconductors, but it's affecting the entire supply chain. And as we were talking about the transformation of the industry and the expectation of both government and consumers towards electrification, towards greater safety, more automation, what we're seeing is this is pulling away resources, financial resources, human resources, and capital that should be used for that transformation, for workforce, for other issues that are facing the industry to get past these new challenges. I think we're all concerned about the length of time that this is going to be there. And then you build on this with other supply chain crises and other issues, the port crisis, the absence of the availability of raw materials. And it really does come to a juxtaposition of both supply chain crisis and transformation. And can we as an industry get past that? I would just like to end exactly on what John was talking about, collaboration. The collaboration is going to be very important. And I think one of the things that has disturbed me, and I think, well, I better not speak for John or I'll get myself in trouble. He's right down the street from me. But disturbed me is that there's been a lot of conversation on Capitol Hill about the investment in chip manufacturing in the United States being under the sort of the discussion of corporate welfare. But I think we've got to think about this in a whole different way. In order to manufacture chips in the United States and to order have some ability for our industry to be able to use these, it really is a matter of competitiveness. We've got to compete against Europe, we've got to compete against Japan, China, and we've got to work as an industry in that collaborative spirit to make sure our policymakers understand that. So with that, look forward to the questions, look forward to the give and take. Thanks so much for having me.
Great intro. Thanks, Anne. One of the questions that came in from the audience is quite basic but interesting, and it's one I'd like to debate a little bit. And we often talk about there being many reasons for this chip shortage, just kind of a combination of things that happened. So the first question is, what's the biggest reason, if there is one? I'm not sure there is. And then, would this crisis have happened regardless of COVID, or did COVID just kind of pull it forward, or could we simply have avoided it altogether? And Dave, I'd like to address this first question from the audience your way.
Sure. I think that's actually a very interesting question and has many aspects to it. I think if we look back over the last year and a half, and particularly in 2020, it was almost the year of the perfect storm for this particular supply chain issue. Yes, as Andreas showed the numbers, we were expecting modest growth across, modest to good growth actually across all sectors. We did see some disruption in those, but, think about early on what happened. COVID hit. That shut down some factories in Taiwan for a few days. So that had a disruption. You saw the dramatic response of the auto industry and reduction of sales and orders for chips. And then that turned back on later on. So that had a shock to the system. But in addition to that, there was some drought issues prior to that in Taiwan that, impacted water supply, slowed some of the manufacturing. There was a fire in a factory in Renesas, a huge supplier to the auto industry. And then the freeze in Texas, which shut down NXP and Texas Instruments for a few days. All, kind of sequential to one another that had huge shocks to the supply system. And so then, once the orders started to come back on, it wasn't just one sector that went down and back up like the auto industry. All sectors were then running at record years. And so the demand across the chip supply was larger than it's ever been from a growth perspective, at the same time that we needed to resupply the auto supply chain. So numerous very critical factors led to this situation.
So Andreas, let me just add on to the comments made by Dave and get your view. One of the things, that you showed in your slides was, all the different industries that use semiconductors. As we know, everything's getting smart, right? I mean, any device you buy today is Wi-Fi enabled. Heck, I can preheat my oven from my phone. I love it. This just continues to grow in terms of demand. So even if we hadn't had COVID and plants shutting down, would we eventually have reached this, just we don't have enough chips for the demand?
Well, we probably, as said, we already have been at a high utilization, and it would have gotten probably tighter over time. At the same time, also there is capacity being built. I think we wouldn't have had an as abrupt shortage as we have seen it now, because I think what just happened is that we saw a little bit what is called in literature a bullwhip effect going through the supply chain. So if you stop the supply chain, then start it again, and then basically communicate down from level to level. At every level in the supply chain, the effect amplifies. So the OEM says we start again, we order parts from our tier ones. The tier ones say, oh, we get demand, we need to order a bit of buffer, we order a little bit more. Next stage orders a little bit more. Until you arrive at the end, the effect is gigantic. And that is, I think, part of what just caused this disruption in the supply chain. And I think which by itself would probably not have been a problem, but just in combination with all of the other factors we were just discussing, that was just the last thing that was too much.
So just with synergistic growth, we would have had the opportunity to build up the supply chain in all the tiers and maybe averted some of this we'll just call it a calamity in the semiconductor world. My next question is also for you, Andreas, and I'm wondering how could this shortage change the way that semiconductor and automotive players will work together in the future? What are some of those big changes or recommendations that we can make to the industry?
But I think first of all, it brought obviously semiconductor on the front and center of the automotive industry. In combination with it already becoming front and center because of connected cars, electric vehicles, autonomous vehicles, and all of those trends, which make just semiconductor way more important than it was in the past. But I think it also shows it's important to work together in this ecosystem across tiers. So I think what we will see much more is collaboration beyond one tier of the supply chain, being it on the design, being it on, for example, defining specifications, but I think now with the shortage also working on supply together and production. And I think that's something to stay in, I think, which is also a good thing, because that is what is needed. As you said, there's all of those trends which make chips more important. And I think that collaboration is needed to successfully tackle that upcoming topic.
Yeah, I think this is a great question for John or to Dave. Both of you kind of touched upon it in your opening comments too. How is that relationship going to change in the future, or how should it change?
Yeah, I'll jump in, Dave, and you can maybe build on or contradict my comments, although I think we're probably aligned on this as well. I think there are a couple of things. One is, there is the how the business itself changes, and Andreas touched on that, right? So just how does the supply chain evolve over time as a response to this? But I also think there are opportunities. Again, I want to go back to collaboration to maybe put a little bit more specificity around this. I think in the near term, there's an opportunity rather to collaborate around the idea of a greater degree of transparency across the supply chain. Look, everybody wants that, including the U.S. Department of Commerce, which has issued a request for information. They're clearly looking for transparency. Now, some of you may not love that request. Some of you may love that request. The fact of the matter is that the Department of Commerce is taking a snapshot and they want to look at that snapshot and understand sort of what the degree of the imbalance is and what's going on. I think if you think about that from our perspective more broadly, and putting the government aside for a second, I think we have an opportunity to collaborate in two ways. One is, I do think that we could, in some way that's mutually beneficial, as supply chain here, do further data analysis to really more deeply understand what's happening, to give more information to the players across, again, across the supply chain. I think the second thing that we should endeavor to do is, I do think that there is an opportunity over time to share data and information in a way that would increase transparency. So again, the Department of Commerce has a snapshot. We could work together to develop a process. Now, we've had this conversation. In fact, that the Department of Commerce has asked us to think about a concept in the transparency space. We've been working with Ann and her colleagues at MEMA, as well as others, to try and develop this. We think there's a high-level concept that could make sense for us to discuss. A lot of conversation needs to take place, and I want to emphasize that it needs to be mutually beneficial for everyone, whether you're producing wafers or whether you are building cars on a final assembly line. But I think that is a discussion we as an industry need to have. How do we develop a process that provides more data sharing to increase transparency and trust along the process?
Thanks, John.
Okay.
I think I'll
Okay.
add to that in that, I think we're in complete alignment on the need for communication, transparency, and ultimately data sharing across the supply chain. I think we're beginning to see some of that collaboration now, obviously out of necessity, but that necessity is driving better communication channels throughout the supply chain. And I think, chips, chips are chips. And, that was kind of the thought, oh, we're just spending, it's just a bigger and bigger piece of the cost of building a car because we're using more and more chips for infotainment, for engine management, for whatever systems management there may be, sensors and so forth. But that increasing content made it that much more critical, a piece of the supply chain, without, I think, a true understanding of the complexities of building a device and how long it takes to do it, as well as bringing on new capacity, because new capacity in the chip industry is not incremental. It comes in big chunks. You build a new factory and you're building tens of thousands of wafers a month. And that factory is built to a certain capacity. And if you need more, you build a new factory. You don't just turn on a new tool. And so, that recognition of how those complexities interplay, I think, is now getting much better understood, across the chain. And we're seeing many of the auto manufacturers, creating their semiconductor divisions that are, very keenly involved in the chip design through the tier 1s and tier 2s and all the way down to the direct suppliers. So I think as a result of this, we're going to come out of this with much more collaboration across the network, the supply network, as opposed to the supply chain, and be able to take advantage of some of the opportunities that are being created by commerce and other funding that may come across the industry in support of that.
Thank you, Dave. And, one of the things that always bubbles in my mind when I hear about, the individualness, I should say, of the different specs and chip requirements is, is it really anybody's USP? Are people buying your car because of the chip that's in it? Probably not. It's for the feature. But anyway, I wonder if we shouldn't do a better job as an industry of reducing the number of those specs. But another question that I have is related to, the increased capacity. We've seen a lot of automakers joining forces with battery companies to, make plants, develop plants, to co-develop product. do we think that this crisis will lead to more of those kinds of partnerships between automakers and chip suppliers and or co-investments to potentially secure that supply? Anybody want to tackle that one?
Well, I think one thing that, I mean, we're definitely seeing a lot of that co-investment. I think there's a lot of different pieces going on to this. This is, you know, as we've all said, an industry that's changing in lots of ways, and with electrification and, you know, just the whole supply chain concerns. I don't think it's just the chip crisis that has driven this, but I think it's the level of investment that's going to be needed for electrification. I think it's the level of investment that's going to be needed for the next safety devices. You know, on any given day, if you listen to our members, it could be a chip shortage, but it could also be the crisis at ports. So then you're looking at how do you, maybe because of tariffs, maybe because of reshoring opportunities, bring things back, either it's reshoring or nearshoring into the United States and have more control over it. I think the chip crisis itself, from what I understand from our members, is part and parcel of that. Perhaps for some of our members, a greater portion of that conversation with their customers, the OEMs, and their suppliers, the chip manufacturers. But some of our other members, it is also tangential to it. So I think it's a wave that we've seen that, depending on where you are in the supply chain, may be the tipping point for you or not.
And that's a great segue into what are the impacts to the suppliers, even those who don't use semiconductors in their manufacturing facilities and don't develop them? You know, what are you seeing throughout the whole gamut of the supply chain?
I think what's really disturbing is that when we talk to suppliers, and I think John hears the same thing from his members, it's affecting it all the way through the supply chain. So that those who are making components and parts that they then sell to a tier one, they may never touch a semiconductor, but if there is a work stoppage at a vehicle manufacturer, they are not selling their parts. And what is going on is we have varying, you know, vehicle manufacturing technology going on in the same plants at differing times, and you have this rotating sets of either layoffs or slowdowns going on, which is extraordinarily difficult to manage in a time where workforce is very hard to get. And so we're seeing a weakening overall of the supply case, because our members, if they don't sell their components, they're not able to make money and reinvest in their own operations. And that's one of the reasons why I keep, you know, been working very closely, obviously, with John and with the other members of the industry, is we think it's so important overall for employment and for the economic well-being of a lot of communities where our members are, for us to make sure that we address this in the most forthright way possible. Again, as a country, we are not going to be able to be competitive unless we address this crisis, because it is being addressed in other parts of the world as it's a global crisis, but we will not be able to be competitive unless we can continue to do so. And I see John's hand up, so he'll probably force me on something.
No, not at all. I love what you're saying, and I want to build on it. I just think, look at the facts on the ground. There is no inventory in dealerships, right? So inventory in August of 21 is 72% lower than it was in August of 2019. Okay, so from 4 million vehicles of inventory to less than 1 million vehicles of inventory, there's nothing for sale. Right, so that gives you, if you look at it from the customer back, you can see the effect on the supply chain. It's extraordinary, right? We can't get vehicles into the marketplace, even with demand running around 17 million vehicles. So sales are going to be 12 and a half. Like, this is significant. And so it is affecting jobs. Ann is exactly right. Plants are idled. Key plants are idled for across the supply base, as well as with regard to final assembly. This is the problem that we're facing. Two things I want to build on. One is I do think there's going to be further collaboration and coordination among companies more broadly to support the transformation. But I think there are two things here. One is this is about our global competitiveness. And so investments in capacity in the United States are critically important. This is why, as an industry, we're supporting government support for, to support investments in the United States in greater capacity. I think this is something that we're all aligned on. And it's important to our strategic position as a country, and our economic competitiveness. And so, I do think there is a role for government here to support. Now, this is going to be a mid to long-term solution, as Andreas said, that would support some of the short-term solutions like that we talked about, like greater transparency and rethinking, sort of how we work through the, supply. But this is really important, and I think we got to get it done.
Dave, I see your hands raised.
Yeah, I just wanted to add on to the point that both Anne and John made relative to cooperative investment and that sort of thing. You asked the question, do we think we'll see the auto industry either individually or collectively investing in building a semiconductor factory? I think not. And the reason I say that is no single factory can, just by the nature of the manufacturing process, can build all the types of chips that are needed in the automotive space. So there is co-investment. So they are making investments in capacity and secure capacity across multiple suppliers that build different types of chips. And, to the point of the government funding that's being proposed, and I think is likely to be authorized, that will go to multiple suppliers. It will go to leading edge manufacturing, as well as the more lagging edge. The 300 millimeter, which is the diameter of the wafer, is typically the leading edge new factories. 200 millimeter is the biggest supplier to the auto industry, and that's kind of not necessarily, as Andreas showed on his charts, not necessarily the leading edge technology, but also needs investment in capacity. And so I think we'll see that spread across multiple companies. And, so because it goes to companies, it has kind of the corporate welfare connotation, but it really isn't. It's really that type of co-investment spread across multiple companies, because no one company, no one factory can build all of the chip types that are necessary to supply the industry.
Thank you, Dave. So, we can utilize and try to simplify, but in general, let's leave the manufacturing to the semiconductor manufacturers and just make a robust supply chain, I guess is what you're saying. I'm going to be a little bit provocative here because I've got some interesting questions that have come in. And, one of the questions is, we hear automotives are using that old technology that's been part of the reason why, we're not being prioritized. And then it's just been reported in general that the chip manufacturers are telling auto, too bad, I'm going to supply to everybody else first. And is that just an impression? Or and now is automotive being seen as a more critical customer in the eyes of the suppliers, or is this all just, everyone's overblown the situation? Dave, I'm going to start with you on this one.
Sure. That's a great question. I think, we get that question sometimes from the supply chain, are we just not important? And it's not true. I think, as we discussed, the shortages across all industries. I mean, just go into Best Buy and see their stock on consumer electronics. It's every bit as impacted as the auto industry, but may not have the same type of, job creation and visibility to the consumer that the auto industry has. Chips are typically about 10% of, auto industry is about 10% of chip production. And growing. So it is an important element of what we supply to. So I don't think that they're being ignored. I think, as Andreas discussed, that bullwhip effect that happened when essentially, after March of 2020, the spigot was turned off. No chips were supplying to the auto industry. 4 or 5 months later, it got turned back on. And during that time period, all other industries also grew. So when we turned it back on, everybody was on allocation. So it wasn't that we were not supplying, it was just that all chips were on allocation. And it does, there's a 4 or 5 month manufacturing process window to get those chips back into the flow. And so there, I think there was an impact to the bullwhip effect, if you will, to that. Now, when you say that we're using the old technologies in automotive, I mentioned it there. It is the 200 millimeter fabs largely that are supplying automotive technologies, and it's not leading edge that goes into high performance computing, but it is keeping pace with the industry. And I think, Andreas, I don't remember the exact number on your slide, but something like 50% of chip production for the auto industry is less than 28 nanometers today. Well, leading edge is 7 and 7 nanometers. So it's in that range, and certainly the processors that are going in engine management and FPGAs and that sort of thing are running at close to leading edge technologies. So that's not at all true either. So
Great. Any other comments? If not, I've got another great question.
I would just quickly add to that, if I could. Keep in mind what we're talking about here. We're talking about a vehicle that needs to operate all the time, every time, right, perfectly, right, for 20 years at 150 degrees Fahrenheit, at negative 40 degrees Fahrenheit, right? These chips, these mature nodes are really important to that, just as they are in defense, by the way. Right. And so this isn't something like, well, gee, I don't know about these auto guys. They're kind of like old school. Like, are you kidding me? I mean, you can't reboot your car at 65 miles an hour. Right. That's really what we're talking about here is durability, always functioning perfectly every single time. And so it's a whole range of nodes, from the mature nodes to the cutting edge nodes, that are going into vehicles today and will continue over time. I'm not quite sure why people don't get that, but that's the reality. The other point I'd want to make here is that that is why the approach that Dave talked about is important, right? You have to make sure that as we think about things like government policy associated with expanding capacity, that all of those nodes are represented in that expanded capacity, all right? Because you do need to make sure that you're able to produce vehicles that are cutting edge vehicles that support the technologies that we've talked about, but that are always working perfectly every time, safely, and effectively. And that's really what we're about, right? That's the most important thing, is delivering safety in personal mobility to our customers every single time.
John, I'm so glad that you raised that point. I mean, those of us who have to reboot our computers, reboot our phones, we do it and think nothing of it. But we know that the customer, when they're in the vehicle, if their Navi system reboots, if they can't connect with their phone, becomes a super major complaint. And we're seeing that in all of the quality score indicators. The expectation is totally different in terms of customers and their demand, and of course, the parameters that the product has to operate in. Keeping you on the screen, we've talked about the auto companies are really doing what they can right now to manage and mitigate the shortage. Supply chain heroes, purchasing, everybody's working 24/7. What, if anything, have you been hearing from the companies on the challenges they're encountering as they work to navigate? What are some of these big headwinds that they're seeing?
Yeah. So a couple of things. One, we've talked a little bit about this, and again, I think Andreas really touched on a number of these issues. One is transparency, right? And perspective across the value chain, what's actually happening. With the bullwhip effect, I think is a good description, but really having a better sense across the entire supply chain of what's happening is certainly something I've heard. The other thing I've heard is, and you're seeing a lot of good work being done by companies and, across the supply chain, is how do we think differently about how we organize supply chains in, given this reality, right? I mean, I grew up in an auto industry where, just in time was absolute gospel. And my first trips through assembly plants, plant managers would point out the lack of inventory on the floor and say, look, this thing is totally clean. There's nothing on the floor. There's no inventory, right? It comes right into the plant from a railhead at the point of fit, and that's how we do things. Is that the way we need to do things going forward? I think that's what companies are looking at, right? And this is why, sort of you talked about the creativity and the thinking going into, the collaboration across the supply base is so important. Do we need to really rethink some of those principles and some of those gospels, so to speak, as it relates to things like semiconductors? And so I think those are a couple of things that are clearly going on. But, again, there's a sense of urgency here in the short term. That I think greater transparency and working together to create a data sharing mechanism could really address. And then finally, capacity. Anne touched on this, I think, really well. It's about our economic competitiveness. It is about trade investment, but it is about investment here as well. So those, I think, would be, three top line things that I'm certainly hearing from the companies we work with every day.
And Anne, I see your hands up to illuminate us on what you're hearing from the companies you work with every day.
I think one of the things that we're hearing that's disturbing is, as everybody talked about, the number of chips might be needed for a component. And what we're hearing from folks is they're wrestling with this daily. So I think everybody needs to think about that. It's 24/7. You've got the folks working on this all the time, but we have managers of technology, vice presidents of technology, who are deciding every day, how do we finish a component? Can we finish a component? Everything from a seat to, more sophisticated components. And those are resources that are not used to having to deal with a daily fight just to finish the component to get to John's, to the vehicle manufacturers and out the door overall. And when we look at the supply chain, and this gets well beyond the policy ramifications of it, but if you get past the 24/7, if you get past just-in-time delivery, what does that mean for smaller suppliers? So a lot of our smaller suppliers are already talking about the price of steel, the price of these raw materials, the price of motors that are coming from China when they have to put tariffs on it. Can they really invest in more capacity and more parts? If it's not just in time, what's that going to do to them? And where is that added investment and assistance going to be? Because as John said, we've seen this with the storms in Texas. We've seen this with other cases. These things are going to change. But how and who's going to help finance this, and what does it do to our localized, smaller supply base is really a big question.
Thanks, Anne. And Dave, I know that SEMI has a group, GAC, the Global Automotive Advisory Council. Are you hearing the same kinds of stories and thoughts from that particular council? And would you like to illuminate us further on maybe some additional thoughts?
Sure. We have the Global Automotive Advisory Council. We actually have them in 5 different regions across the globe. We have it in North America, Europe, Japan, China, and Taiwan. And, the participants are from the OEMs and tier 1s all the way down to the equipment and materials manufacturers, including, some of the interim groups like Uber and others that participate that are kind of changing it, as well as the device manufacturers. And so we're looking at, as I mentioned in the beginning, we started looking at what drives the future, autonomous systems or electrification, and what's the important elements there, building a silicon carbide wafer specification inside the SEMI organization. What are some specification around data transfer, electrification, drivers, that sort of thing. We're also looking at reliability, as John mentioned, as a critical element of automotive devices, reliability at the advanced node semiconductors. So we have a working group that's continually looking at what are the requirements to make sure that the devices meet the reliability aspects at the leading edge nodes. So it's really looking at those issues. Of course, the supply chain issue is one that's come up and come on very strong in the last year as topics of discussion. And as I mentioned, we're starting to see that collaboration and a better understanding in both directions of, one, from the automotive manufacturer's perspective, the complexities of the semiconductor manufacturing process and supply chain, and then from the device makers, the methodologies of supply chain management. I think we will see that just in time will evolve to something different moving forward for different types of components that are being supplied. It probably works for forgings and things like that can be readily stamped out, but for something that takes 6 months to manufacture, there will be a different methodology. And so we'll have a whole new school of thought on supply chain, I think, after we come out of this crisis.
Yeah, I think we're seeing that across so many industries right now. I know that I've been told by a number of in a number of conversations I've had lately that the number of warehouses being built right now is just increasing exponentially, and it's multi-industries, looking at where do they have risk, what should they stockpile, what should they keep as just in time. It's going to be a whole new world in the future, and we'll get into kind of the future side, I think, starting from now. And I have a question for Andreas, because you've been too quiet for too long. When we have had several questions from the audience about this as well. When we look at the future of automotive with autonomous driving, connectivity, electrification, what does that mean in terms of semiconductors and volumes and, increase of use? Is this just going to keep going up and up and up?
Yeah, that's an interesting one. So if I think I have to take it down by the different trends. Let me split it in ADAS autonomy and into electric vehicles, starting with the electric vehicle side. So what we see currently is going from internal combustion engines to hybrid electric vehicles, especially plug-in hybrids. We see a huge increase in the content. That is because you have both powertrains. You have the electric powertrain and you still have the ICE powertrain. And at some point, we will then go from a hybrid to a pure battery electric vehicle. And battery electric is the route we go. At that point, actually, we'll reduce again the number of chips a little bit, because just this internal combustion engine with everything that's part of it, with all of the motor controls, etc., just falls away. So I think actually that's an interesting, because what that means is that we are now going towards a peak and then we're slightly coming back. A very different story on the ADAS side. On the ADAS side, we're just increasing content as we're going to autonomous vehicles. I think one thing that's special there is for a self-driving car, even more than for any other applications, this can never fail. Because in that case, in the best case, the car basically has to stop and can't move anymore. In the worst case, we have a much worse outcome. So I think here a big question is, how can we design systems in a way that are fail-proof? Do we need redundancies? Do we work without redundancies at some point? So how do we solve that? Demand both on the quality of chips, but also the number of chips.
Thank you, and I welcome other thoughts on that. Andreas, something seems wrong with your microphone. You're very garbled at the moment. If you have another headset you can use, it would be appreciated. Anybody else want to talk about this, kind of exponential growth in terms of, what we're going to see in the vehicles in the future?
I would just say that, Andreas's points are exactly right. I mean, both of those, those shifts, those mega trends, electrification and ADAS towards self-driving are going to drive increased demand. I think it is interesting, Andreas's sort of, perspective on, ICE to hybrid significant, and then maybe hybrid to battery a little bit less demand, but overall, you have to think of the vehicle as one system. And so those vehicles are going to be both battery electric and ADAS. So overall, the trend is very significant increases in demand in the automotive sector, right? Because you're not going to have a battery electric vehicle that isn't going to have ADAS, and you're likely not going to in the future have an ADAS vehicle that isn't battery electric or isn't, you know, plug-in hybrid or hydrogen fuel cell. So you've got to see these mega trends as informing each other and together accelerating a broader transformation and therefore greater demand for microprocessors and chips.
Thanks,
Yeah,
John.
and if
And
I could,
oh,
if I could
go
just
ahead,
add to
Dave.
that, when we go to autonomous vehicles and interface and interconnectivity with the smart infrastructure, then we've got to consider, you know, downloading of huge amounts of data. And with that, there's storage requirements. There's certainly processing requirements. So, you know, there'll be edge processing solutions in the vehicle, more so than there are today, to transfer and process that data on just an ongoing basis. And so as we go to autonomous, you know, it's not just thinking in terms of what the systems are using today and the growth of that, it's what else is needed to enable that entire infrastructure and vehicle system.
So let me talk a little bit and let's think a little bit about how government and industry can be working together. How can they be working together to solve it? You know, this may just be, as already been evidenced by some of the comments with the Department of Commerce in the study, this may just be kind of the tip of the iceberg. Yeah, we have semiconductors, but we have this, and this coming, especially with vehicles getting smarter and moving into the realm of electrification. What do we need to do to start that dialogue and ensure that it's taking place with the right people? And, you know, who are those people or groups that need to be deeply involved in this conversation for, you know, securing the future of supply? John, I'd like to kick this off to you first, if I could, and then others can join in.
Okay, great. I want to start with your where you ended that question, which is who are the people, right? Who are the key players? I think, and then we can build out from there. Look, I think there are certainly, with regard to the U.S. government and policy development, really three key institutional players. One is certainly the Department of Commerce, the U.S. Department of Commerce, and I would say that Secretary Raimondo has shown great leadership in this space and a sense of urgency about not only wanting to understand further what's happening, but also using her, I'll say, convening authority to bring the industry together. We've all of us in this, many of us in this meeting have been in some of the same virtual meetings with the secretary and her senior staff on this. And so we'll talk a little bit more about what she's doing in a second. I think the other major institutional player is the White House National Economic Council under the leadership of Brian Deese. A quick note, Brian Deese sort of, I don't know if he'd appreciate me saying this, cut his teeth perhaps in the auto industry sector as a key member of the auto task force during the Great Recession, where he was a key player in trying to understand what was required to support the industry during that time. And so he has, I think, in some ways, a unique perspective now in this broader economic role to understand the value chain, understand the supply chains, and understand the economic competitiveness of the auto industry. So those are some key players. I think there are a couple of things that are going on that I think are important. You referenced as did I, the request for information. Look, I think that's important. I think it's important for all of us across the value chain to participate in that, because it's going to not only provide more perspective that hopefully we can get as industry participants from the Department of Commerce, but they're going to have to make decisions. For example, if, as Dave says, the CHIPS Act funding happens, they're going to have to make decisions about how to allocate those funds. That's going to happen through the Department of Commerce. So let's provide them with important information. I think another thing they're doing that's important at the intersection of policy and innovation is, you know, the development of an early warning system where you don't have to run around the federal government looking for somebody to tell when you see a snag in the supply chain. that they've streamlined that process to allow, certainly in the near term, COVID-related snags and bottlenecks to be identified, and that would allow the U.S. government to come at this with a much more coordinated and quicker response between Commerce and the State Department than others. So I think that's also good. I think they're also, looking at developing an Office of Supply Chain Resiliency, which gets to some of the broader strategic questions that have been raised here. So, look, I think those are, and then the last key institutional player, of course, is the Congress, as Dave said and Ann said. Look, we do need to be thinking about this from a strategic perspective. And so there is a role of Congress in supporting, whether it's funding or other tools to support further investments here in the United States so we can control our own destiny. So that's in my view, who the players are. Those are some of the, I think, things that are important steps that policymakers are taking that we need to be engaged and coordinated on.
Go ahead, Ann.
If I might, I think the other thing that we should not discount is the importance of local governments, whether it's governors or it's economic development offices, because they really understand when we start to talk about, manufacturing of batteries for battery electric vehicles, or R&D work on ADAS technology, or some of the investments that are being made for these new transformational vehicles. They understand what that does for local government. And I really think that the industry doesn't do enough to tell the governors, this is why it's important, and this is why you need to weigh in on all the parties that John just mentioned. Because I mean, absolutely, those are the key players. But what we've got is a disconnect going on here, where folks think up on Capitol Hill, and I think less so with Commerce and the White House. I think they understand why these investments are necessary for competition. But there's some folks on Capitol Hill who still don't see that connection between the ability for this country to compete and the investments that are going to be necessary to be able to do that. And I think we should push that lever at the local level and state level more than we do on a normal basis.
Yeah, that's a really, really good point. And that cooperation between the state level and between the US is really, really important when we look at further incentives and or assessing where we have companies at risk. It's really quite critical. Andreas, I'm going to try to ask a question to you. On the global level, are you seeing other nations that seem to be moving faster? Are you seeing any best practices in terms of the government industry working together for this crisis?
Well, I think definitely we see actions across the globe. I mean, it's a problem for every country, and everyone is taking actions. I think reactions are a little bit different. But I think, for example, even last year, just since I'm originally from Germany, still following the news there, so there were news that, for example, the government was actively trying to secure chip capacity even at a diplomatic level. So things like that are happening, and the governments do everything they can on their side as well. Yeah, I think how much can the government really do in the short term? Yeah, they can coordinate, they can try to help on a diplomatic level to secure capacities. I think the things that we discussed, but I think in the long term, the question is really, as I think was raised before, how can we stay as a nation competitive and make sure we have the chips we need in the long run, and how can the government support on that side?
So the reason I asked that question was then to ask another question about, how can we do a better job of maybe leveraging our relationship with some of our allies? There's a lot of people talking about we need to have all of this domestic. Do we need it all domestic? Should we be looking at, even more robust than that? It's not an all or nothing scenario. So if you have a comment on that, and then I want to have some of the other panelists kind of address this distribution network, so to speak, and how we can better enhance our relationships with those that we do business with.
No, I think one of the charts I've shown was about the imbalance between supply and demand. And we are very far from having all the supply that we need domestic. So even if we increase now the domestic supply, we will still have to import. And so with that said, I think it continues to be important to maintain just open trade across the globe and to be able that we can continue to import the products that we need. And as you say, that involves making sure we have close ties with other nations and maintaining those ties.
Thank you. Are there comments from others?
I'll step in and, you know, it's been a long discussed issue around national security from Department of Defense on chip supply and access to leading edge and secured supply chain, recognizing that it is a global supply chain and that, you know, even if we manufactured all the devices from a wafer manufacturing standpoint in the US, there's not a lot of packaging capabilities. So, you know, that still goes to Southeast Asia or China for packaging. And then, you know, it can go back and forth for test, you know, it says that, you know, a chip probably goes back and forth, you know, 7 times, you know, from region to region around the world before it ends up in its final destination. And, you know, logs, you know, some 20,000 miles in their frequent flyer account or more for every device that, you know, gets produced. So there are those aspects, but, you know, from a regional investment standpoint, if you go back more than 4 decades and look at, you know, the various regions looking at semiconductor technology strategically as a, you know, strategic industry for the future. So Japan in the 80s, Korea followed that, Taiwan followed that in the late 90s, and China. And so now, you know, we have a, you know, global manufacturing base that's significant, and you know, the proportion of manufacturing done in the West is much smaller, but it's being done in allied countries, you know, Japan, Korea, Taiwan, Europe. They're all allied countries, notwithstanding some of the geopolitical concerns, you know, today. But you know, I think it's not going to go back to being strictly a regional production issue. It's always going to stay a global supply chain. Now that supply chain may shift from country to country at times for different elements, but you know, the investments are being made, and as Andreas pointed out, there's announcements, you know, that have been coming out over the last several months from nearly every region of significant investment in building the capacity.
And Anne, what are you hearing from your members? Do we need 100% of our chips to be manufactured in the US?
Well, I mean, I think, you know, Andreas and Dave said it right. It's not going to happen. I think one of the things we have to do is we have to really, you know, one of the disturbing trends in another disturbing trend in conversation is how much is US capacity? I mean, how much can we demand of US manufactured capacity for a finished vehicle in the United States? And I think this country needs to balance what we should be making in this country and what we should also be making other places. But at the same time, it's a global supply chain, and we depend on a global supply chain. And I think that's one of the things that we have to continue to sort of beef up the conversation within this administration about the importance of it and the value that it brings to the United States by that support of that global supply chain. But what we do need is we do need capacity in this country. And that's why passage of things like the CHIPS Act, passage of, you know, a supply chain resiliency program within the Department of Commerce, that early warning system, all those things that John was talking about, that's why those things are so important.
Fully agree. So I have 2 questions, and the first one came from the audience. I've seen it over and over again. And by the way, someone in the audience did ask if we would share the presentation, and I believe that we will. Sarah will get into the chat or into the Q&A and answer that question for you. One of the questions, though, is when is this going to end? So I just want everybody to take a minute or 2 and answer that, and then I'll have our closing question for the session. Anne, I'll start with you since you're face up on the screen.
When is it gonna, you would start with me, Carla. You owe me coffee for that one. I hear from our members that we're we're into next year for sure. And, maybe beyond that, I think the announcements have been the level of concern. The question is it at the level, when you look at what we're talking about, collaboration and transparency, are there ways to alleviate some of the burdens? So that some of the things I talked about of the day-to-day crisis management, can we help either minimize that or alleviate that? But I think the beginning of the year, we all thought it might be over at the end of this year. That's not what I'm hearing now.
Yeah, probably a premium coffee to it, that, a real fancy one with the whipped cream.
Yeah.
Andreas, how about you?
Yeah, no, I fully agree with what Anne just said. That's also what I hear. I think that this is not going to be over this year. I think we will go probably way into next year. And then I think the question is just how much disruption can we mitigate with the actions we are taking, but it's not that we will go off rationing immediately.
And John?
Yeah, look, the truth is we don't know how long it's going to last. And that's the frustrating aspect of this. And it's like a mirage. It kept on getting pushed out, right? Well, the end of 2021, now the end of 2022 into 2023. If you look at, whether it's Andreas's analysis or, IHS Markets or GD Power, I mean, this goes into 2023, I think, at least. And so that's a huge challenge for us, is that we don't know. And again, and now I'm sounding like a broken record, but this is why I think collaboration around data sharing as an industry together, maybe, with a third party we all agree with and trust, is so important, because we don't know the duration of it, and it is affecting business and it is affecting customers, and we can't respond to demand. So we need to figure it out.
And Dave, do you have any crystal ball?
Well, I'd say John gave the right answer. We simply don't know.
Yeah.
But I think, if we polled the audience, we would get a pretty broad distribution from first quarter of next year to, 2025.
Yep,
But,
for sure.
I think the general consensus is towards the end of 22 into, early 23. That's when, some of the new capacity that's being built will come online, that starts to alleviate the supply issues. But it is, it's a moving target, and it's difficult to predict, but I'm certain we're through it most of next year.
So I'm going to ask one last question and give everybody a minute to address it. And it is, what do we need to do to prevent these future shortages? What's next? How can we manage it? And if we were to have this conversation again in 5 years, what will have happened, or what do you today wish will have happened, so that we're not discussing these same issues again? And Dave, since you're on the screen, I'll put you up first.
Sure. I think, obviously we're going to do some analysis of this current situation as we go through, and analyze what, have a new kind of look at what the supply chain looks like. And it becomes, I think, a much more collaborative network of the value chain, as opposed to just talking to the link that is next to you. So I don't think it will be automotive manufacturer to tier 1 to tier 2 to device maker. It will be a collaborative discussion. I think there needs to be broader visibility and risk assessment at all levels of the supply chain, and I think we will do that through sharing of data. I think John is absolutely right that that visibility and transparency comes through sharing of data. And so it's really it's not just going to be related to chip supply. It's going to be the way we manage supply chains for any type of component as we go forward. And we will certainly learn a lot from this, but it will be a collaborative environment with much more transparency and visibility across the chain. And
John, since Dave called you out, I'm going to call on you next.
Thanks for that. And I agree with what Dave said. Again, I mean, I do think there are lessons learned, but both from the, with regard to the business, the supply chain aspect of the business, as well as the collaborative aspects that we've also talked about. But I want to broaden this, because I do think this could be a preview of coming attractions if we're not careful. In other words, that as we think about the mega trends, the transformation of the industry, that if we're not careful, we could see this same set of supply chain effects applied to, for example, the raw materials, critical minerals, and key components of electrification, for example. And if you look at the supply chains, we have similar challenges, right? Where are we getting our raw materials right now? Where are those raw materials processed? Where are they becoming batteries? Where are they becoming cells and packaged? And where do they end up in our market, right? That value chain, that supply chain, to my mind, faces similar challenges. And so I think we do have to address this shortage, this challenge, but we also have to apply the lessons we're learning here to this broader question of supply chain resiliency in a transformed mobility space.
Thank you, John. And Andreas.
Yeah, and just adding to that, I think there's a little bit of a trade-off between efficiency of the supply chain and stability. And we'll probably see more erring from a extreme at this point of pendulum at efficiency, and it will swing more towards reliability, meaning we have probably will see more stock at different levels of the supply chain. We will probably see a bit more spare capacities and not run the supply chain as tight as we did in the past.
Thank you, Andreas, and I'll let Anne's comments end the panel.
Oh, thanks. Thank you. I think I agree with everyone, but I would say it comes down to three basic issues. It comes down to domestic investment. We've got to invest domestically, not just when we talk about semiconductors and chip manufacturing, but in infrastructure for our ports, in access to raw materials, and R&D to find alternatives. We've got to invest in domestically. And we've got to then also embrace the fact that we're a global industry. And that means that we've got to minimize tariffs. We've got to take care of export control issues, all those types of very tedious, difficult, expensive issues that we're all dealing with. And then finally, all the business and commercial issues that Dave and Andreas and John mentioned. The collaboration and the transparency is going to be necessary. But I think all three of them are going to be necessary, because it may not be the chip crisis in 5 years, but as John mentioned, we're already facing these issues on a number of different raw materials, finished goods, and we've got to address this.
Thank you so much, everyone. You know, for me, it's in 5 years, I want to be sitting here and saying, you know what, we analyze this and we're now proactively attacking it and we're not reactively managing it. So hopefully we can get there even sooner than 5 years. I'd like to thank everyone who participated on the panel, and Dave, John, Andreas. Excellent conversations. We could have talked much longer. Maybe we'll have a round 2 in the near future. To the audience who participated and joined us for the whole time and asked such compelling questions, I really appreciate that as well. I wish you all have a great rest of your day.
Thanks so much.